Hello, good morning children. Today we are going to discuss the topic on circles. According to our NCERT book, our next topic, that is chapter 10, is circle, children. Right? So see, first of all, we should know all the basic definitions of the circle, children. Of course, in the lower classes, in the previous classes also, you have studied regarding the circle, children. Right? Now, see, as we define the circle, so of course our first basic requirement is the definition of the circle, children. As we see the figure for the circle, children, here, see, this is what? This is the locus of the point, or you can say collection of the point in a fixed pattern. So how we can define the circle, children? It is a collection of the points on a same plane which is equidistant from a fixed point. Suppose this is a fixed point. So from the fixed point, if you see, if you mark any point, suppose this is a point A, and if you meet the distance of a fixed point to the point A, you will find this distance is fixed, and this is called the radius of the circle. Right? You mark another point on this, and you see, when you meet these distance, you will find OA will equal to OB. You mark another point on this circumference of circle, suppose C. So you will find OA equal to OB equal to OC. What does it indicates? Our definition is कि circle is a collection of the point, or you can say locus of the point, right, which is equidistant from a fixed point, is called the circle. Clear, children? So first we define the circle. So we write a collection of points, children. How we write? A collection of point, okay? Collection of points on a same plane, which are equidistant from a fixed point, children, from a fixed point, right, is called circle. So in this way you will define a circle. Now, two words came, fixed point. So you can say the fixed point is called center of the circle. The fixed point is the center of the circle, and the fixed distance, I have already shown you the distance from center to any point on the circle. So the fixed distance is the radius of the circle. Right, children? Radius of circle. So see, children, this is the basic requirement for the circle. We should know what is the circle. It is nothing, but it is just the collection of the point, or you can say loci of the points which are equidistant from a fixed point, is called circle. And of course the fixed distance, here I have taken the fixed distance as a fixed point as a O. So from a fixed point, so fixed point is the center, and the fixed distance OA, as I have shown in the figure, OA, OB, OC, these are the fixed distance. So the fixed distance is called the radius of the circle. This is the basic first requirement of the circle, children. Whenever we study the circle, we should aware with the basic definition of the circle. Right, children? Okay. So now see, the circle is clear, fixed point is clear, and the fixed distance is clear. Okay. Now, so of course these are the basic definitions and we require, and you see the diameter and the radius, relation of the diameter and the radius, that I will show you, and few more terms we require in our syllabus according to our NCERT textbook, children, right? So I'll just define you circle, center, radius. Okay. Now see the other requirement for the circle which we needed over here, children. See, what are those requirements? See, this is a circle. Again I am drawing a circle. This is the center, right? Center I marked here O. And now see, what is this, children, called? This AB. AB is nothing but it is called the chord of the circle, children, right? And when this chord passes through the center, children, when this chord passes through the center, suppose this is CD, this chord is called the diameter of the circle, children. So this is the diameter, and you are knowing the distance between center to any point on the circles. Center is O, point is D, is called the radius. So OR is the radius, OC is the radius, children. So in this way we can say diameter, that is D, is nothing but it is the 2 of the radius. Small r indicates the radius and capital D indicates the diameter. Or you can say radius is the half of the diameter. So this is the relation in the radius and the diameter. So see, children, this is the chord. How would you define the chord, children? A line segment, listen it carefully. How would you define the chord? A line segment whose end point lies on the circle, children. As you can see, AB is the line segment. Line segment means what? Having the fixed end point, right? So a line segment whose end point is on the circle. On the circle means circumference of circle. That is on the boundary of the circle. That is the meaning of on the circle. You are knowing the difference. On the circle, in the circle, and outside the circle. In the circle means interior part of this circumference, that is circular boundary, right? And on the circle means on the circumference of the circle, or you can say on the circular boundary of the circle. And exterior, of course, outside of the circle, that is outside of the circular boundary. When any point will be in the position of outside of the circular boundary, or you can say exterior of the circle, then its distance from the center will be greater than the radius. So this is one of the way to identify whether the particular point is on the circle, in the circle, or exterior of the circle, children, right? So when we can say कि any point is in the circle, if the distance of that point from the center is smaller than the radius, then we can say the point is interior of the circle. And if it is equal to radius, any distance of that particular point is equal to radius, then we can say it is on the circle. And if the distance of that particular point from the center is greater than the radius, then we can say it is in the exterior of the circle. So these are the three positions of a particular point to identify whether it is in interior of the circle, exterior of the circle, or we can say on the circle, children. Good morning, children, to all of you. I'll already wished you good morning, very good morning to you all. Listen it carefully, the concept. Those who are attending me. Okay, children. Now, the next requirement. Now see, definition of circle over, meaning of circumference over, radius over, center of the circle over, okay, diameter of the circle completed, chord of the circle completed, and the relation in the radius and the diameter we have completed. Now few more terms, of course, which are new for you, for in this class 10th children, are like this. One of the term you require, secant of the circle. So how would you define the secant of a circle? See, children, S-E-C-A-N-T, right? Secant of a circle. See, I'll draw one more circle here to show the secant, right? If a line is passing through a circle in two distinct points, if a line passing through a circle intersecting in two distinct points, then it is called the secant of a circle. So this is called the secant of a circle. So this is the secant, children. Right? One more term you require. So how would you define the secant? Secant, you can write the definition for the secant, right? A line intersecting the circle. In a short form you can write a line intersecting the circle at two distinct points. At two distinct points is called secant. In this way, in a short form, you can define the secant of the circle, children. Right? A line intersecting the circle at two distinct points is called the secant. One more important term we required, children, here, right? That is the tangent of a circle. So how would you define this tangent? Now see the next part, that is the tangent, children. So see, this is the circle, this is the center, and if a line intersect the circle at a single point, children, or you can say a line just touches the circle at a single point, it is called the tangent of the circle, children. So this is the tangent. Okay, this is very important term which you needed in this year, children. Of course, this is the center and this is called the tangent of the circle. So how we can define the tangent, children? A line intersecting the circle at a single point. How we define? A line, this is tangent, this is the explanation for tangent, children. Okay, so I'll put the heading tangent, and of course this is the secant, and this figure is for the general information, right, children? So a line intersecting the circle at a single point. A line intersecting the circle at a single point, okay, is called tangent, children, is called tangent. So this is the definition for tangent. A line, I'll again repeat, a line intersecting the circle at a single point is called the tangent. This is the position of the tangent, children. This is the position of the secant, children. A line intersecting the circle at two different points. Okay, I'll name it L, and two different points as a AB is the secant, Okay, I'll name it something, suppose M, intersecting the circle at a single point, that is at point P, is called the tangent of the circle, children. Now, see one more thing you will get from here. First I'll make the space to discuss that one more point is there with the tangent. If you can see, children, the point P, which is the common point of the, if you can see here, see this figure, look at this figure, tangent, point P. If you can see, P is a point of the tangentum, but children, P is a point of the circle also. That means P is a common point of tangent as well as the circle. Right, children? So this point P has the special name, children. Right? This is called the very good point of contact. Someone, Raj Singh, very good. It is called the point of contact. Right, children? So this point P is called, I am circling this point and writing here, this point is called point of contact. Right, children? Point of contact. Okay. So how would you define the point of contact? Right? So here we define the next term as a point of contact, children. Right? How we define this point of contact? A common point of circle and tangent is called the point of contact. How would you define? A common point, right? A common point of a circle and a tangent, right? Common point of a circle and a tangent is called point of contact, children. It is called the point of contact. Okay, children? So see, all the terms which we needed in this year, okay, over. Basic definition for the circle, right? Center of the circle, radius of the circle, okay? Then the most awaited points are secant and the tangent of the circle. Okay? Because whole the concept is on the secant and tangent of the circle, children. Got it? So we got the idea regarding the secant of a circle. It is a line intersecting the circle at two distinct points. Tangent, it is a line intersecting the circle at a single point is called the tangent of the circle. And the point which is common of the tangent as well as of the circle is called the point of contact, children. Right? Okay, so these things over. Now, further, if we proceed to the next part, if we see in the same figure, children, circle, center, tangent, see again I am drawing the figure. This is a circle, this is the center O, this is a tangent, this is the P, point of contact. See, children, as I told you, the position of point which is equidistant to the radius from the center is on the circle, that is on the circumference of the circle, children. So see, if we join this point O and P, children, you can see it very well, O and P. So see, what you get, OP is the radius of this particular circle, and this is what? This is the tangent, right? What is the P? P is the point of contact, children. P is the point of contact. Again I am repeating the term, point of contact. From this basic requirement, I will tell you the most awaited theorem, that is the theorem 10.1, which is very important on the exam point of view, and generally the board is asking this theorem, that is called the, very good Raj Singh, the tangent is perpendicular to the radius of the circle. In short, we can name this theorem as a tangent radius theorem, children. What is this called? Tangent radius theorem. So if you can see, this is the radius, this is the tangent, this is the point of contact, which is the end point of the radius also. Point of contact, P is the end point of the radius also, children. Getting? So this radius is always perpendicular to the tangent at a point of contact. So this is the theorem as a tangent radius theorem. So now we work for the tangent radius theorem. Okay. Last year they asked only two theorems we are having, children, here. Okay. One theorem is theorem 10.1, that is the tangent radius theorem, and another theorem is the tangent from exterior point to the circle are equal, that is the theorem 10.2, children. Right. Now both the theorems are important, and alternate year they ask the one of the theorem from this topic for the either 3 marks or the 4 marks, children. Okay. So don't avoid the theorems of the chapter circle. Okay. So first theorem is theorem 10.1. You can refer your NCERT textbook also, children. Right. In short, we can name this theorem as a tangent radius theorem, because tangent radius theorem. Why I am naming this as a tangent radius theorem? Because when we solve the problem on this, right, children, we will not write the complete statement. Simply we write by tangent radius theorem. Okay, so the examiner will get the idea कि actually what the child want to say or express on the answer sheet, or which concept he is applying here. Right? Okay, children. So now first we write the statement. If you can see the statement, it is on the page number, if I can see, children, 208. The statement I'll read for you, it is given also. The tangent at any point of a circle, children. What is the statement? The tangent at any point of a circle is perpendicular to the radius through the point of contact, children. Right? So first I will write the statement. The tangent at any point of a circle, the tangent at any point of a circle is perpendicular, right, children? The tangent at any point of a circle is perpendicular to the radius, where? Through the point of contact, or you can say at the point of contact, through the point of contact, children. Right? The theorem statement. for the theorem 10.1. You can find the statement and the proof of theorem in your NCERT textbook, also in the page number 208, children. Okay, so what is the tangent radius theorem? The tangent at any point of a circle is perpendicular to the radius through the point of contact. So see children, according to the statement, of course now I will make the short figure because I need the explanation also, space also to prove this theorem, right children? So let's see. According to the statement, the tangent at any point of a circle. So children, suppose I'll draw a circle here. This is a circle. Okay, the tangent at any point of a circle. This is the tangent, right? This is the center O. Okay, tangent, suppose I'll name it L, or suppose AB. I am naming the AB. Okay. And this is the point P, point of contact, and this is the radius OP, children. Okay, this we have to prove perpendicular, right children? So now see, what do we do? Let it be L only if you want. Okay children, so according to the statement, tangent of any point of a circle is perpendicular to the radius through the point of contact, children, right? So suppose I will name this side something, instead of L, suppose I name it X, Y, or something else. Okay, so first according to the statement, what do we do children? First we write the given. How you make the given over here children? Okay, O is the center of, let O be the center of a circle, O be the center of a circle with the tangent XY at point of contact P, children. Right? So this is the given according to the statement, and the figure we drawn, let O be the center of a circle with the tangent XY at point of contact P. Right children? This is the given. Now to prove, what you will prove in this children? What we have to prove according to the statement? We have to prove कि OP is perpendicular to XY, children. What we have to prove? OP is perpendicular to XY, children, right? Now see children, to prove this theorem, we don't have, you can take circle center as a O and R. Yes, you can take it. It's on you what you want to take, but the concept must be proper. Okay, from the one chat, someone is asking the center as a O and this as a radius R, OR. Yes, you can take it. Okay, it doesn't matter. Now see children, to prove this theorem, we don't have the mathematical expression, children. Only argument is there, right? How you make the argument? First I'll explain the argument, then I'll do the writing work, children. Okay, so how would you make the argument to prove that OP is perpendicular to XY, children? See children, if we can see, there is only one point P on the tangent XY. This is a common point of the circle and the tangent both, children. Okay, suppose if I'll take another point other than the point P, children. Suppose I am taking here a point Q, right? Now join the Q, children, O to Q, join the center to Q, children. See, this will be the OQ, right children? And this is the point P. So now see children, the position of the point Q here. Where will be the position of point Q? Of course, if you can see, O greater than the distance of OP. And what is the OP? You are knowing it very well. OP is nothing but the radius R. So if the distance of OQ is greater than the radius OP, this means point Q is in the exterior of the circle, children. Right? So whatever point we take on the line XY other than the point P, children, we get all the point in the exterior of the circle other than the point P. Now see, whatever point you will take on this XY, all the point will be exterior of the circle other than the point P, children. Why? Because if we take, suppose OQ is smaller than the radius, for example, so suppose OQ is smaller than the radius, suppose here you are getting the point Q, then what will happen? This tangent XY will become like this, I'll show you, see, like this. That means this will become what? This become the secant of the circle, right? So if the distance of point Q from the center is smaller than radius, okay, then XY will not be the tangent, it will be the secant, children, right? So only one point on the XY which is equal to the radius is point P only, children. Other than the point P, whatever point you will take on the tangent XY, their position will be exterior of the circle, children. That means those points distance from the center cannot be equal to radius, children. Have you got it? I'll again repeat. Except P on the tangent XY, whatever point we take, their position will be exterior of the circle, children. P के अलावा हम कोई भी पॉइंट XY पे लेंगे तो उन सारे पॉइंट्स की पोजीशन एक्सटीरियर ऑफ सर्कल ही आएगी, क्योंकि उस पॉइंट की डिस्टेंस सेंटर से ग्रेटर देन द रेडियस होगी। मीन्स केवल P ही एक ऐसा पॉइंट है जिसकी डिस्टेंस सेंटर से रेडियस के बराबर होगी। Hence we can say कि OP is perpendicular to the XY. So see children, this is a total argument, right? You don't have any mathematical expression to prove the first theorem, that is the tangent radius theorem, children. Okay? Got it? Getting? Now, so how to begin the proof for tangent radius theorem, children? So see, we write only the argument whatever I just discussed with you, children, right? What do we write here? We write take a point Q on XY other than P. Okay? So whatever I discuss, I'll write here. Take a point Q on tangent XY other than point P. Right, children? Other than point P. And join OP. Right, children? So this is the first point which I'll explain you. Ki if I'll take any point on XY, as I have taken the point Q other than the point P, okay, and then join the OQ, so its distance will be greater than the radius. So for this we have to give the argument, children. Okay, so what will be the position of point Q? So definitely the point Q must lie exterior of the circle, children. The point Q must lie exterior of the circle, right? Because, why? Give the reason also. Because if Q lies interior of circle, if Q lies in interior of circle, okay, then XY becomes a secant and not a tangent. This is the reason behind that, and not a tangent, children. So this is the first line explanation, कि if we take a point Q other than the point P, and when we join O and Q, okay, so point OQ must lie exterior of the circle. Why? Because if it lie in interior, then this XY will become a secant and not a tangent. Right, children? That means, therefore, we can say, okay, OQ, distance OQ is greater than the radius OP, right? Distance OQ is greater than the radius OP. Why? Because P is in exterior of circle, and if it is in exterior of circle, it represents कि this distance is greater than the radius OP. And see, this thing is applicable for all the points on the line XY other than the point P, children. So we write this statement, we continue. I'll need the space, children. Okay, so now I'll clean this part given and that, okay, and here I'll continue the proof. Okay, so only this much argument is there, and we write कि this condition or situation is possible, or you can say is true for all the points, on XY other than point P. Right, children? Other than point P, children. Right? That means there is only a point P, children. There is only a point, other than point Q, not P, children. P is the contact. Okay? This condition is true for all the points on XY other than the point Q. Right, children? This means what? OP, only OP is the shortest distance. That means, in short you can write, that is only point P is of shortest distance from center. Okay, that is equal to radius, children, equal to radius. Hence you can say OP is perpendicular to xy. This is over children. So this is only the argument. आपको थोड़ा सा बोरिंग जरूर लग रहा है लिखने में, है ना, लेकिन अगर कंसेप्ट अपन को क्लियर हो गया है तो अपन अपने वर्ड्स में भी इस चीज को लिख सकते हैं, कोई बहुत बड़ा इशू नहीं है इसका, ठीक है। कंसेप्ट बस इसमें एक छोटा सा इतना है कि P के अलावा एक्स वाई पे हम कोई भी पॉइंट लेंगे टेंजेंट एक्स वाई में, इफ वी टेक एनी पॉइंट ऑन टेंजेंट एक्स वाई अदर देन द पॉइंट P, इट्स पोजीशन ऑलवेज बी एक्सटीरियर ऑफ द सर्कल। दैट मीन्स कि केवल OP P ही एक ऐसा पॉइंट है जो सेंटर से शॉर्टेस्ट डिस्टेंस पे है, ठीक है, जो कि रेडियस का एंड पॉइंट भी बन रहा है और टैंजेंट का भी पॉइंट बन रहा है। Hence, we can say कि OP is always perpendicular to XY, और P के अलावा हम कोई भी पॉइंट टेंजेंट पे लेंगे तो उसकी पोजीशन हमेशा रेडियस से ग्रेटर होगी। That's it, children. Got it? So I hope you have understood this concept. So you revise this concept once, twice, and for any doubt you can directly contact me or make the comment on the comment box only. Okay children, so for today only this much, and tomorrow at the same time at 11:30 we will continue the exercise 10.1 with the second theorem 10.2, that is tangent from exterior point to the circle are equal. Yes, Hardik Dwivedi. Okay, thank you, God bless you all children, thank you very much.